Section 15.4, Green's theorem. I'm going to leave example 1 and 2 for you because you're going to get exactly the same thing. Let's start with number 3. And we're going to verify Green's theorem by evaluating both integrals. The first integral on the region C, which is the vertex, a square with the vertex 0070 and 7707. Then we have to verify the second part, and we have to get two equal sides. So first of all, I did a graph the regions here. We got this square. Then I need to find the R of a T. The first thing, if you start from this point to this point, you can take any path, start from any path. I start from the point 0, 0. So if you look to this point, X is going to fix 0, but the change is going to be on Y. Y, so it's going to be T. And T is belong between 0 and 7. Then the second path here from 0 to 7, X is going to be changed, Y is going to be fixed. So X is the change, Y is going to be fixed, and T between 0 and 7. The third path is going to be from this point to this one. So the change is going to be here. This is 7. The change here is going to be X is going to be 7. And the change is going to be on Y. And T between 7 and 0. Then the last part is going to be from this point to this one. The change is going to be on X, and the Y is going to be 0. So here is the points we have here. So the integral, here is our function, is going to be y squared and x squared, because this is m and this is n. So now let's find the integral for each one. So the integral from 0 to 7, which is the first one, y squared. So I'm going to work on this one. Y squared, which is, this is the y. This is x, and here's y. So I'm going to plug in y squared is going to be t squared. Dx, the derivative for the x is 0, dt, plus x squared. X squared is going to be 0 times the derivative of t is going to be, which is the y, is going to be 1. dy is going to be 1 dt. Plus the second one, the integral from 0 to 7. Y squared, that's mean 7 squared. Dx, which is dt, 1 dt, plus x squared, which is t squared, times the derivative dy, which is going to be, derivative of 7 is going to be 0 dt. So here is, this is 0, this is 0, and also this is 0. That's the only one we have it here. Plus the third path here. This is x and here is y. So y squared is going to be t squared dx, which is 0. Plus x squared, that means 7 squared. dy is going to be 1 dt. This is also 0. Now, the last region is going to be y squared is going to be 0 squared times 1 dt, and x squared, which is t squared, dy, which is 0, the derivative of 0 is 0 dt. So this is 0, this is 0. Then left only this one and this one. So I'm going to write down here 7 squared 49, 7 squared 49, find the derivative for each one. So 49t from 0 to 7, 49t from 7 to 0, and it's going to be 49, 7 minus 0, 49, 0 minus 7 is going to be 343 minus 343, which is equal 0. So this is the first part. Now let's find the second part, the integral from 0 to 7, 0 to 7. The derivative of n with respect to the x is going to be 2x. You have to go back to f of x, which is, this is n, m, and here's n. So the derivative for n is going to be 2x. the derivative of m is going to be 2y. So it's going to be 2x minus 2y dy dx. Let's keep going. Now find the derivative for y. So it's going to be 2xy minus 2y squared over 2. Cancel the 2 with this one. So plug in 7. So it's going to be 2x7 times 7 minus 7 squared minus 0 dx. So it's going to be 14x minus 49 dx. Find the integral with respect to the x. So it's going to be 14x squared over 2 minus 49x from 0 to 7. Then it's going to be 7. Simplify this one, is going to be 7x squared minus 49x from 0 to 7. And it's going to be 7 times 7 squared minus 49 times 7. So 343 minus 343 also is going to be 0. So we prove that both these integrals equal to 0. So we're going to put 0 here. I'm going to put 0 here. We got it right. Let's move to number 4. Again, you're going to get the same thing. I'm going to try to solve this example for you. So number 4, we need to use the green theorems to evaluate the line integral. So we have to find the integral for this one for the given path boundary line between the graphs y equal x and y equal x squared minus 2x. So the first thing I'm going to find, so here is the integral and here is the boundary. So we're going to find the intersection point between these two lines. This is curve and here's the line. So x equal x squared, and move the x to the other side. It's going to be x minus 3, and we have 0 and 3. So 0, x, and 3. Now let's graph this line. You're going to let x equal 1. You're going to get y equal 1, x equals 0, y equals 0, x equal 2, y equal 2. You're going to get this line. You graph this line, let x equals 0 is going to be y equals 0. X equal 1 is going to be 1 minus 2 is going to be negative 1 here. X equal 2 is going to be 4 minus 4 is going to be 0. When x equals 2, y equals 0. When x equals 3 is going to be 9 minus 6 is going to be 3. So we got this curved line here. So here is the intersection point, and here is another intersection point. So we need to find, here is our region R. That means the integral is going to be for the x from 0 to 3, 1, 2, 3. And for the y is going to be from this curve, which is this one, to the line, which is x. So from this curve to the line x. Derivative of n to the x. So here is m and here is n. With respect to the x, it's going to be 2. The derivative for m with respect to the y is going to be 1. So 2 minus 1 is going to be 1 dy dx. Find the derivative is going to be y from x squared minus 2x to the x. Then plug in these is going to be x minus x squared minus 2x dx. Distribute the negative sign. And so it's going to be x plus 2x is going to be 3x and negative x squared. Now find the derivative with respect to the x. So it's going to be negative x cubed over 3 minus 3x squared over 2. Plug in the 3, so it's going to be negative 3 cubed over 3 minus 3 times 3 squared over 2, which is equal, here is negative 9, because 27 over divided by 3, negative 9, minus 27 over 2, multiply by 2, so it's going to be 9 over 2. Let's check that. Yeah, here's the whole thing. This is a plus. There's a plus. So it's going to be negative 18 over 2 plus 27 over 2. So it's going to be 9 over 2. So for number 4, it's going to be 9 divided by 2. That's it for number 4. For number 5, I'm going to leave that for you. You're going to do exactly the same thing. But be careful here, you're going to use the region with the theta. For number 6, let's check number 6. So for number 6, use the green theorems to evaluate the integral. And we have the boundary region lie inside the rectangle with the vertex 9, 5, negative 9, 5, negative 9, negative 5, and 9, 5. And the outside, the square of the vertex. So here is the vertex for this square is inside, which is here inside. So here is negative 1 on this one. You have to add down a point. So this one is negative 1. Negative 1, 1. And here is 1 and 1. And the point here is x is 1, y is negative 1, and here is negative and negative. So we need to find the region. So the integral for this region is exactly the same thing. The derivative of n with respect to the x, the derivative of m with respect to the y. So this is m and this is n. So it's going to be the derivative of n is going to be 2 minus 1. So that means it's the integral for the region, the same region, which is the just go ahead and find the area for this region. So here is the vertex for these integrals. That means the distance from here to here, which is 9 units, and the distance from here to here is 9. So this length, the length is going to be 18. And from here to 5, and the distance here is 5, that's mean 10. So 18 times 10 is going to be 180. That means the area for the whole rectangle is 180. Now the distance from here to here is 1 and 1, so it's going to be 2. And the same thing here is 2, so that's mean 2 times 2 is going to be 4. So 180 minus 4 is going to be 176. So that's it for this example. So 176. You got it right. Now let's move to number 7. Number 7, we need to use the Green theorem to evaluate the line integral y squared dx plus xy dy and the boundary region between the graph y equals 0, y equal square root of x, and x equal 25. So here is the integral, and here is the region y equals 0, y equals square root of x is going to be this curve, and you're going to curve it by let x equals 0, y is going to be 0, x equals 4, y is going to be 2, and here's the x is 25. So that means the integral is going to be from 0 to 25, and from y equals 0 to y equals square root of x. The derivative of n to the x, here is n, and here is m. To the x, so it's going to be y. The derivative of m to the y is going to be 2y. Y minus 2y is going to be negative y. Then find the integral with respect to the y, so it's going to be negative y squared over 2. Plug in square root of x, so it's going to be negative x over 2 minus 0. This is 0, so it's going to be negative x over 2 dx. Then it's going to be negative x squared over 4. We're going to find the integral with respect to the x. And then plug in is going to be negative 25 squared over 4 minus 0. This is 0, so it's going to be negative 625 over 4. That's mean for this one is going to be negative 625 over 4. That's it for section 15.4.